In this video, we're going to look at the chain rule. The chain rule is probably the most widely used rule for differentiation. It's found in the formula booklet and states that y is equal to g du, where u equals f of x. Therefore, dy over dx is equal to dy over du times du over dx. The chain rule uses substitution in order to make differentials easier to perform. You can use the formal rule for differentiation using the chain rule, or when you're more confident, you'll be able to use the quick method that I will show you after example 1. So, in example 1, if f of x is equal to 5x squared minus 3 raised to the power of 8, find f dash of x. So the first thing I'm going to do is let u equal 5x squared minus 3. So if I take the differential with respect to x, I get du over dx is equal to 10x. I'm going to rewrite the original equation using u. So I get y is equal to 5x squared minus 3 is now u. So I get u to the power of 8. Now I'm going to differentiate. So I get dy over du is equal to 8u to the 7. Therefore, using the rule, I know that dy over dx is equal to dy over du times du over dx. If I now substitute them in, I get dy over dx is equal to 8u to the power of 7 times 10x. But I know what u is, so therefore dy over dx is equal to, I'm going to bring the 10x to the front, so I get 10x times 8. I know what u is. It is now 5x squared minus 3 raised to the power of 7. Simplify the front, so I get dy over dx is equal to 80x 5x squared minus 3 to the 7. Therefore, using f dash of x is equal to 80 brackets 5x squared minus 3 to the power of 7. Now you can use the quick method. So what you actually did was, the first thing you did was multiply by the power. So you multiplied by 8 in this case. The bracket remained the same. So you've still got 5x squared minus 3. You substituted 1 from the power, so 8 minus 1 is 7. And then you multiplied by the differential of what's inside the bracket. So the differential of the bracket is 10x. Now you can sort it out. 8 times 10x gives you 80x, bracket 5x squared minus 3 raised to the power of 7. So f dash of x is equal to 80x brackets 5x squared minus 3 to the power of 7. So basically the steps that you took were 1, multiply by the power, 2, bracket stays the same, 3, subtract 1 from the power, 4, multiply by the differential of the bracket, 5, tidy up. Now we're going to go through 8 further examples using the quick method. So question 2, y is equal to 6x squared plus 7x raised to the power of 7. So dy over dx is equal to multiply by the power, so 7. Then you've got 6x squared plus 7x. Take 1 off the power, becomes 6. Multiply by the differential of the bracket. Well, the differential of the bracket is 12x plus 7. So now let's tidy it up. I'm going to bring that bracket to the front, so we get 7 brackets 12x plus 7 brackets 6x squared plus 7x to the power of 6. Question 3. F of x equals 1 over 3x minus 4 raised to the power of 5. First thing we've got to do, we've got to bring the bracket to the top, so we get it's equal to 3x minus 4 raised to the power of minus 5. Therefore, f dash of x multiplied by the power, so we get is equal to minus 5. Bracket remains the same, 3x minus 4. Take 1 off the power, so it becomes minus 6. And then multiply by the differential of the bracket. Well, the differential of 3x minus 4 is 3. Now we can tidy up, so we get f dash of x minus 5 times 3 is equal to minus 15. 3x minus 4 to the power of minus 6. Question 4. Y is equal to the third root of 5x plus 6. Make it into a power, so that we get y is equal to 5x plus 6. Third power is to the power of a third. So we get dy over dx is equal to 1/3 5x plus 6. Take 1 off the power, minus a third minus 1 is minus 2/3 times the differential of the bracket, which is equal to 5. Now let's tidy it up. 5 times a third is 5/3, so we get dy over dx is equal to 5 over 3, 5x plus 6 to the power of minus 2 over 3. Question 5. F of x is equal to cos 5x squared plus 5. Well, the differential of cos is minus sine, so we get minus sine 5x squared plus 5 times the differential of what's in the bracket, which is 10x. So therefore we get f dash of x is equal to minus 10x sine 5x squared plus 5. Question 6. Y is equal to e raised to the power of 5x plus 4. Therefore we get dy over dx is equal to e always remains the same, so we get e to the power of 5x plus 4 times the differential of 5x plus 4, which is 5, giving us dy over dx is equal to 5 e raised to the power of 5x plus 4. Question 7. G of x is equal to the natural log of cos x. Well, when you differentiate the natural log, you get 1 over. So we get 1 over cos x times the differential of cos x. Well, the differential of cos x is minus sine x. So g dash of x is equal to minus sine x over cos x. Well, minus sine over cos x is minus tan x. So g of x is equal to minus tan x. Question 8. H of x is equal to log brackets 2x cubed plus 8. Therefore, h dash of x is equal to 1 over the bracket, which is 2x cubed plus 8, times the differential of the bracket, which is 6x. Therefore, h dash of x is equal to 6x over 2x cubed plus 8. And the final one, y is equal to e raised to the power of sine 3x. That gives us dy over dx is equal to e sine 3x times the differential of sine 3x. Well, the differential of sine 3x is 3 cos 3x. So let's tidy that up. So we get dy over dx is equal to 3 cos 3x e to the power of sine 3x. You can, of course, at any time use the formal definition of the chain rule to differentiate, but it is a lot quicker, especially in an exam, to use the quick method that I've shown you on 8 occasions.